Kornucopia ML, enhancing analysis of test and FEA data in MATLAB. Analysts and test engineers need to combine and assess data from various sources, physical tests and simulations, often coming in a variety of units. They typically need to manipulate tons of this data that is often messy, nonlinear, and noisy. From their analysis, they need to find and derive knowledge, which will guide engineering and business decisions. Throughout this process, they need to organize their ideas and document their calculations, ultimately creating traceable, reusable workflows. Let's look at the traditional analysis approach. In this approach, we typically work with just the numeric data. Our first step is to separate the data from everything else. So now we end up with a data array where we're not exactly sure what the columns or rows are, we have no knowledge about units, the source of the data, or any other meta information that might be important. Next, computing with just the numbers, we note that units are not tracked, and unit conversions, if they are used, are typically buried manually in calculations. It is then noted that when we plot the arrays of these numbers, there's typically no annotation applied to the plot by default, and it must be applied manually if done at all, which results in unclear communication. Ultimately, the traditional approach is inefficient and error-prone. Kornucopia ML is an improved approach based on three primary components. First, it has an efficient and intelligent data handling architecture that allows you to work with all your data, the numeric portion, the units, the descriptions, column names, and other important meta information. Second, Kornucopia has a broad analysis toolbox for real-world, messy, noisy, nonlinear data. And third, this is all supported by a teaching help system. Kornucopia ML provides advanced data analysis that also reduces errors and automates your workflows, saving you and your colleagues large amounts of time. The foundation of the Kornucopia toolbox is a new data type called K_units. This data type, inspired by MATLAB's table data type, allows you to hold in a single tabular-like variable a numeric matrix, its related units, descriptive text, and meta information. Through Kornucopia's seamless unit engine, you can directly compute in MATLAB with the new K_units data type, allowing for cleaner MATLAB scripts and less mistakes. Here's a typical Kornucopia variable being presented in MATLAB. This is a typical calculation that one might use. The key points here are, we have an organized tabular data format, where equations and commands are easy to read. Kornucopia handles all the units-related portions of the calculations, and your analysis is clear and accurate. Since Kornucopia's K_units data type holds all this information, it is easy to create highly informative plots. Here are two examples of Kornucopia graphs where the smart and automatic labeling of the plots is enabled by the K_units data type. With Kornucopia ML, you can quickly create fully labeled plots without any manual editing. Kornucopia's plotting features offer simple-to-use options for advanced formatting. For example, it is easy to add a summary table on graphs and figures. All of this allows you to create efficient presentation quality plots, which is a huge time savings. In contrast, the traditional approach of just using numbers often requires additional manual manipulation to properly label plots. When multiple figures are being created, it is common that each figure is individually edited, resulting in a time-intensive process for generating properly labeled presentation quality graphs. Kornucopia ML, for use with MATLAB, is truly the horn of plenty. Its foundation is the K_units data type, and it has many tools built upon this foundation, beginning with automated text file importing and parsing, as well as third-party file importing for Abacus and Spectral Dynamics impact software. Kornucopia has a variety of other tools also, including data adjusting, cleaning and curve averaging, string creation and manipulation, numerical integration and differentiation, a variety of DSP tools for doing filtering and spectrum analysis, specialized shock response tools to calculate absolute acceleration and pseudo-velocity shock response, highly automated plotting and labeling, flexible text writing, and an educational help system. Kornucopia ML allows you to work smarter and faster. Here's a typical data file that comes from the MTS data acquisition system. There are multiple stacked data sets. The header sections have data and units in them, and the tabular portion of the data comes with column names and units as well. This is readily analyzed with Kornucopia using just a few functions. The k_read text and k_plot functions can automatically read the file in and parse it, and then quickly produce this automatically labeled plot, where we see we have a little bit of cleanup to do. This is easily done with a few other Kornucopia functions that allow us to trim, tweak, shift, and average the data to produce this useful average curve shown here. Kornucopia is also quite powerful when analyzing noisy data with filtering. Here's an example of some test and FEA simulation data from a penetration event. Using Fourier spectrum analysis, we can understand over what frequency range the data is potentially similar, and then apply a filter to find out that indeed the FEA and test information is quite similar within a common frequency band, ultimately turning a mess to success. With Kornucopia ML, you get faster data analysis with greater understanding, because you get to work with all your data, numbers, units, and text. This enables flexible and more accurate workflows, giving you and your team greater confidence in your results. There are tools to process messy and noisy data for solving important real-world problems. With efficient plotting that has automatic labeling, you can quickly and clearly communicate your results. And our real-world template examples allow you to jumpstart your solutions. This is all supported with a teaching help system that allows you to learn more and grow your value. Kornucopia ML improves the speed, precision, and effectiveness of you and your team. Let's further consider the traditional approach, where you do not work with all your information. So you're only working predominantly with numeric data. Here's an array that's holding some information related to some materials. And here's a calculation where I'm going to calculate thermal stress in a constrained rod, applying a change in temperature, and computing a stress. Obvious questions we have are, what are the columns and rows? And what about units? And where did this data come from? And what are the units on this result? It is not clear in this calculation approach. With the Kornucopia ML approach, we hold the data in a well-described variable, and then we can use natural and clear MATLAB syntax to calculate the stress in a constrained rod, where now we're applying units to the temperature change, and our formula is much clearer. The calculation also handles all the units, and it's quite easy in Kornucopia to convert to different units, ultimately resulting in a very clear output. The k_units data type holds all your data, units, and more, and is easily seen with the variable viewer that Kornucopia provides, where you not only see the tabular data at the bottom, but you can also see additional descriptive information and column comments that may be associated with your data. Kornucopia ML is based on a powerful units engine. So if you enter equations like this in MATLAB, where we're defining a weight, converting it to a mass, and then defining a stiffness, and ultimately computing a natural frequency, where we've used mixed units in this calculation, Kornucopia will handle all that and produce a natural frequency as shown, where it's clear that Kornucopia works well with mixed units, including combining things like US customary or SI in the same equation. Kornucopia does more than just work with the units, it helps check the units. If you were to enter an equation like this, where we added a force 50 newtons to a mass, Kornucopia will produce an error, telling you that you're using incompatible units. It describes the problem, gives you guidance on what to do, and also gives you links to the help system for more guidance. The key point here is that Kornucopia ML is superior to a simple units converter. It is a true general-purpose units engine that handles mixed units based on something called unit signatures. The software is designed to efficiently work with huge data sets that ultimately enables flexible workflows that reduces errors and saves time. Can you spot the error in this calculation of the natural frequency of a beam with a centered concentrated mass? First, we show the calculation using the classic approach, using just numbers. This information here in green are just comments for the user. The MATLAB compute engine ignores them. Thus, the MATLAB compute engine is only working with the numbers. Calculating the equation, MATLAB reports the natural frequency is a little over 52, and the engineer reports this as 52.7 Hertz. Is this correct? Can you tell? Kornucopia can. If we repeat the calculation, but using Kornucopia, we now apply units to the data. So instead of just having them in a comment, the MATLAB compute engine, supported by Kornucopia ML, will now properly perform calculations, including the units. In this particular case, we get an error, and Kornucopia has found a problem with our equation. It has told us that around the plus sign, there are incompatible units. Further assessing, we see we've missed some parentheses. After including them, the calculation is completed, but the units seem strange to us. So while this is valid from a units compatibility viewpoint, it is the wrong equation. So Kornucopia is still helping us to detect something wrong with our analysis. One more look at our equation, we see that L squared should have been L cubed. So now we can complete the calculation, including even doing a few units conversions, to get a result that we're confident in. Kornucopia also robustly handles thermal calculations, allowing you to naturally work with all various measures of temperature: Kelvin, Rankine, Celsius, and Fahrenheit. Kornucopia also helps you safely deal with the affine temperature issue. Consider a temperature of 100 degrees Celsius. If this represents the temperature of boiling water, then its conversion to Fahrenheit would require an affine conversion, which would include the 9/5 multiplication factor and the 32-degree offset. In Kornucopia, this is simply done by including the affine on option in the conversion request. If, however, the 100 degrees Celsius represented a change in temperature, often termed a delta T, then the conversion to Fahrenheit would be non-affine, meaning the 32-degree offset should not be included in the conversion. In Kornucopia, you simply use the affine off option in the conversion request. This approach is cleaner and easier than you remembering different multiplication and offset values for various temperature conversions. Using Kornucopia within thermal calculations allows you to use all forms of thermal-related units, including mixed ones and the dreaded English thermal units. Kornucopia's units library is large and modifiable. It's based on a true units engine that uses a variable's unit signature. This is much more than just a simple units conversion table. It properly tracks unit compatibility in all your equations, allowing you to comfortably use mixed units. And it robustly processes temperature, including the affine units conversions. The library has hundreds of units predefined. Typical ones like meters, newtons, seconds, and such, and some more odd ones such as slinch, furlong, fortnight, or cotton count. You can easily add or modify units in the library using simple function definitions like these. And it's simple to control the units in your output via unit preferences, where you can use either predefined unit preferences or easily create your own. Here is a video showing a few of the units in the library, where literally hundreds of predefined units exist. Kornucopia ML's powerful features work naturally in MATLAB. There are over 80 overloaded MATLAB operator and functions, so that you can do math very naturally in MATLAB. All of these functions listed here understand the K-units data type. In addition to that, there are over 90 native Kornucopia ML functions to do a large range of common tasks. Most analyses start with the importing of data. Kornucopia provides flexible and robust functionality for getting your data into the MATLAB environment. For text files, Kornucopia will semi-automatically parse header sections, column names, units, and data into one or more K-units variables. It also has recursive folder searching that naturally supports design of experiments to allow you to find and load large numbers of files stored in a tree structure on your hard drive. This allows you to easily mine for and load historic data files. From other software, such as Abacus and Spectral Dynamics, Kornucopia makes importing easy because it automatically labels column names, applies the units, and brings back additional meta information related to the data. Here's a few examples of the type of text files that Kornucopia can easily read in. They range from files with no header information whatsoever to very complicated stacked data files. These files are all read in with these two advanced functions. Perhaps you have a more complicated file such as this Abacus input deck that you want to be able to manipulate in MATLAB. This is easily read in with this function. Let's take a further look at one of the examples of automatically processing a text file. Here's a text file that has some header text with two different regions in the header text as well as tabular data below that. Using the kReadText function, we can easily read that file into a smart tabular variable as shown. Using Kornucopia's unpack header function, it is easy to turn this section of the file into a useful variable that can then be used in calculations to turn this raw, low displacement data into useful stress-strain curve, where the equations are easy to read and Kornucopia has handled all the issues of mixed units. Now that we have the data calculated in the form we need, we can clearly plot our results using these two Kornucopia functions to yield a result that provides automatic labeling, a legend, and a title. Let's look at an example of fast and easy data cleanup. Here we have 4 data files. These are easily read in with a simple for loop and this Kornucopia set of commands. The data comes in a cell array in which each of the entries are a KUnits data table. It is noted that the kReadText function has automatically parsed the header, as well as provided traceability of where the data came from. Then using this single plotting function, we can produce a graph that contains all the data, including a legend and labels. Next, we need to clean up the data, so these few commands will trim the data, regularize it, smooth it to get rid of some of the noise, tweak it to extend the data, and ultimately produce an average curve. As you can see, the script is orderly and quite tight. Lastly, we maybe want to plot this in a different set of units, so Kornucopia's plotting function gives you lots of flexibility with additional options to do this. Now we have the data plotted in both metric and US customary units. The key points are we have a clear, traceable workflow that automatically labeled all the plots, including units in the analysis. This is an extendable approach that saves large amounts of time. Kornucopia is also able to import spectral dynamics impacts data, so that you can turn a folder of data files into a well-labeled variable as shown here. The key point is that during the import, Kornucopia ML automatically handles all column naming, documentation, and the units. A similar type of automatic import is available for Abacus workflows. Using this function, we can easily browse to find the file of interest, select the unit system for the model, select the history items and steps we want to import, and then Kornucopia brings in this variable. Again, the key points are that Kornucopia ML automatically handles all the column naming, documentation, and units. Kornucopia ML has a variety of tools to make analyzing shock data quick and easy. Here's an example of an acceleration pulse from an impact event. The data is stored in a well-labeled Kornucopia variable. It's very easy to integrate this acceleration data to compute transient velocity, where Kornucopia has handled all the units issues related to the calculation. The next step in the analysis is to produce a shock response calculation. Using these simple functions here, we calculate the shock response for both an absolute acceleration and a pseudo-velocity spectrum, and then with these simple commands, we issue the plots, resulting in these well-labeled plots. Again, the key points are that the shock response was easily computed for multiple forms, where again Kornucopia handled all the units issues, and we had clear plots, including the complex 4-coordinate plot that was easily created with the Kornucopia functionality. Kornucopia makes cleaning messy data easy and controllable. Here's an example of some data that comes from a high-speed tension test being pushed to its limits. Similar types of data can come from explicit dynamic simulations. The goal in either case is to clean up the data to create a credible stress-strain curve for use as a material model. Here's a MATLAB session using Kornucopia's K-smooth function to interactively clean up the data. Behind the scenes, the function is using Kornucopia's robust DSP technology, but the user interface of the function is designed so that it can be easily controlled with an intuitive smoothing factor. As this factor is increased towards 1, the data is increasingly smoothed. At the end of the process, a credible representation of the material's nonlinear stress-strain response up to failure is created. Kornucopia offers a variety of high-level functionality in MATLAB. Here's an example for computing a discrete Fourier series of data, the so-called FFT. Following the directions of MATLAB's help, these are the commands you would issue to compute the DFS of data. With Kornucopia ML, you would simply apply these two commands to get the result computed and plotted. An additional benefit is that Kornucopia will check the sampling rate of the data to ensure it is constant. If it is not, an error message will tell you what to do, including how to fix it via Kornucopia's regularization function. Kornucopia provides robust technology for explicit dynamics data. Processing explicit dynamics data requires special algorithms that most DSP software does not offer. Issues that are addressed by Kornucopia include constant changing sample rates, massively oversampled data, relatively short signals, time delays, and end effect distortions, as well as other filter-induced distortions. Kornucopia has specially designed DSP technology to address all of these issues. Along with our robust software, proper training is encouraged, where you can learn how to safely output data and avoid aliasing. The course teaches you how to properly apply a complete strategy from outputting data to analyzing data for not only transient dynamic problems, but quasi-static problems as well. Via our training, you will learn how to apply filtering with confidence. Using the right DSP tools is important. Here's a simple example of a sliding contact problem solved with Abacus Explicit FEA. 5 different analysts using the same model get very different results for this problem. It appears that the first 4 are quite similar and that Bob's result is almost 2x larger. Here's the result of the actual underlying transient solution. The pack appears to have a result that is completely implausible, and Bob's result appears to be quite accurate. So perhaps we should hire Bob. If we look at this a little bit closer, we can see the raw data and the various filtered results in this analysis. One of the key things you see is that with the same FEA data, wildly different results can be achieved from various software and filters. Bob's accurate result was produced by Kornucopia. With Kornucopia ML, you get faster data analysis with greater understanding, because you get to work with all your data, numbers, units, and text. This enables flexible and more accurate workflows, giving you and your team greater confidence in your results. There are tools to process messy and noisy data for solving important real-world problems. With efficient plotting that has automatic labeling, you can quickly and clearly communicate your results. And our real-world template examples allow you to jumpstart your solutions. This is all supported with a teaching help system that allows you to learn more and grow your value. Kornucopia ML improves the speed, precision, and effectiveness of you and your team.